In this video, we will cover the purpose of doing combustion analysis and the procedure taken to adequately set up the combustion on engineered air DJ equipment operated by a CenCon or base controller. A combustion analysis is performed on indirect fired equipment that uses a heat exchanger to separate the combustion gases from the air circulating within the building. Adequate air-to-fuel mixture is important to ensure efficient energy transfer through the heat exchanger, maintain equipment longevity, and reduce the number of pollutants released into the environment. Two of the main components released are oxygen and carbon monoxide, which combustion analyzer is designed to measure. There are different types of gas detectors available, therefore check if your analyzer is intended for flue gas analysis. Be sure to periodically send your combustion analyzer to a certified instrument calibration facility to verify its accuracy. A combustion analysis should be performed by a qualified service technician during initial startup of the equipment, in biannual intervals, when the controller is replaced, when the combustion blower or modulating valve has been replaced, or when the equipment is suspected of producing odors associated with incomplete combustion. For the most accurate readings, the analyzer probe should be inserted into the flue collar of the heat exchanger, or depending on the flue configuration, as close as possible to the flue collar. This will help ensure that the measured flue gases don't include added air from gaps in the flue vent connections. On the DJ series equipment, you will see either the base controller accompanied by a CDXM expansion module, or the CenCon controller accompanied by the JXM and CDXM expansion modules. The CDXM can be located either in the control cabinet or within an enclosure in the burner cabinet. This module is responsible for modulating the combustion blower. Inside the burner cabinet is where the gas and combustion components are located. The common components associated with the burner manifold typically include the pilot valve, manifold pressure regulator, main gas shutoff, there may be one or two of these, modulating valve, and main manual shutoff valve. There are also two test port plugs located on the inlet side of the manifold upstream from the regulator and on the elbow just before the piping enters the burner box. The combustion blower is located on top of the burner box. On the side of combustion blower is an adjustable inlet air slide, the Pac-Man, and the combustion blower speed sensor and magnet. Combustion measurements are affected by the air-fuel mixture ratio. Begin by connecting one pressure gauge to the inlet gas pressure test port and a second gauge to the manifold pressure test port. If you only have one pressure gauge, you may have to first test the inlet gas pressure at 100% firing rate, then switch over to the manifold gas pressure test port when the inlet gas pressure is within specified range. The inlet gas pressure range and manifold pressure rating can be found on the ETL label located on the control cabinet door. For this example, the maximum inlet gas pressure is 14 inches water column, which is the maximum acceptable static pressure. The minimum inlet gas pressure is 6.5 inches water column, which is the minimum acceptable inlet pressure when the burner is operating at 100% firing rate. The rated manifold pressure is 3.4 inches water column and is also set when the burner is at 100% firing rate. If you haven't already done so, you will now need to connect to the CenCon or base controller with your laptop, tablet, or compatible smart device. If this is your first time connecting to the controller, please refer to the CenCon Connecting to Laptop video manual for more details. Verify that the equipment is on and the supply air blower is running, then go to the JXM page. Here you can verify that the E and H terminal is energized. This is what enables the burner to light off. Now go to the JXM combustion tab. By pressing the service mode button, this will put the burner into manual override mode. Therefore, if the burner is not already on, you will hear the combustion blower start up and go into pre-purge. Then the burner will light off and go into the firing rate shown here in the percent override. This override can be changed from 4 to 100% to match the combustion curve matching points shown here. The combustion air and gas offsets are what determines the air-fuel mixture and can be changed to correct the combustion curve. The gas offsets are set up from factory testing and typically shouldn't be changed unless you are reclocking the gas. Therefore, typically only the air offsets should be changed if necessary. This table represents the 6 points along the combustion curve that must be verified and the order in which to check them when completing combustion analysis on a CenCon or base controller. The first column represents the firing rate percentage that you'll type into the % service override box. The second column represents the range in percentage of excess oxygen that your combustion analyzer should be reading at an inlet combustion temperature of approximately 21 degrees Celsius. Keep in mind that air and gas become denser as its temperature drops. Therefore, it's typical to see higher oxygen levels on an outdoor unit when ambient temperatures are below 0 degrees Celsius. These oxygen ranges are listed in the CenCon and base technical manuals for reference. The third column represents the typical CO level readings in parts per million that you'll measure from your analyzer. These ranges are for reference only, and anything under 100 parts per million of CO is considered adequate. While completing the following steps, monitor the discharge air temperature to avoid exceeding 180 degrees Fahrenheit or dropping below 40 degrees Fahrenheit, which will result in tripping a high or low temperature limit. To begin, press the service mode button and enter the first service override percentage as 100. Monitor the RPM demand and feedback, as well as the milliamp demand for the modulating valve, to ensure that these figures are relatively stable before checking your measured values. Ensure the inlet pressure has not dropped below the minimum rated inlet gas pressure listed on the ETL label. If the inlet pressure has dropped below this rating, you'll have to increase the pressure on the inlet pressure gas regulator. Verify that the measured manifold pressure matches what's stated on the label. It is acceptable for the manifold pressure to have a deviation of 0.3 inches water column from the rated value. If the manifold pressure is not within range, adjust the manifold pressure regulator accordingly. Compare the measured oxygen percentage in parts per million of CO to the values listed in the first row of the table. For this example, the ambient temperature is 18 degrees Celsius, and we're measuring 4.8% oxygen. The Pac-Man combustion air slide should be adjusted closed to bring the oxygen level within the specified range. Anytime you adjust the Pac-Man, recheck the manifold pressure to verify it's still in range. Anytime the manifold pressure is changed, it will affect the oxygen reading, and anytime the combustion oxygen is adjusted, the manifold pressure also changes. Note that the air and gas offsets for high fire are set to 0, and any adjustments at this firing rate are made mechanically through the combustion air inlet slide or the gas regulator. Next, enter 90 into the service override box. Once the RPM demand, feedback, and milliamp signals have stabilized again, wait until the combustion analyzer measurements have also stabled and compare the O2 and CO measurements to the values on the second row of the table. If the oxygen levels are out of the specified range, you can adjust the combustion blower RPM by increasing or decreasing the 90% air offset. Next, enter 4 into the service override box. As the air and gas demand drops, watch for unwanted spikes of CO. A CO spike of more than 200 parts per million typically means the curve matching will need to be adjusted. Once the RPM demand, feedback, and the milliamp signals have stabilized again, wait until the combustion analyzer measurements have stabilized and compare the O2 and CO values to the third row of the table. It may take a couple minutes for the oxygen and CO levels to fully stabilize. If either the oxygen is out of range or the CO is excessively high, the low fire adjustment is located on the modulating valve. Under the blue cap is a screw that will reduce the gas flow when screwed in or increase the gas flow when screwed out. The air offset should typically be set at 0 on low fire, but in some cases needs to be adjusted. However, it should never be decreased enough to allow the combustion blower to operate below 950 RPM. Curve match is checking the remaining 3 firing rates, 10%, 25%, and 55%. Start by entering 10 into the service override box and wait till everything stabilizes before comparing to the tabulated values. If the measured value for this firing rate is outside the specified range, make the necessary changes to the corresponding air offset. Repeat this for the remaining 2 firing rates. When finished, unclick the service mode button, which will allow the controller to transition back to auto mode. If any offsets were changed during this procedure, you must go to the Save and Load tab and press Save Settings. Otherwise, the next time the controller loses power, it will revert to the original settings. Some things to watch out for when completing a combustion setup. When increasing or decreasing the combustion offsets, take note of where the RPM and milliamp signal was on the previous firing rate. It's important not to have these firing rates cross over, or it could cause poor combustion. Record any combustion analyzer measurements with the combustion cabinet door closed. This will reduce any oxygen spikes from wind gusts. Combustion blower feedback signal issues could result from a bad magnet, poorly located speed sensor, or insufficient grounding of the shielded wiring from the speed sensor. On DJ series equipment with a max trail modulating valve, ensure that the locking rings are all the way at the top and locked in, and the small vent hole is plugged. Also verify that the tubing between the valve and the burner box is inserted properly and pointed towards the burner. For more information, refer to the CenCon and base technical manuals or phone our technical support line.